In this question, we have been asked that which of the following compounds have an asymmetric carbon atom. Now, an asymmetric carbon atom implies a chiral carbon atom. All the four atoms or all the four groups attached to the carbon atom have to be unique, they have to be different. Now, let us examine the carbon atoms in the four compounds given one by one. To this carbon atom, there are two hydrogen atoms attached, hence it is not asymmetric. To this carbon atom, there are two hydrogen atoms attached. This is also not a chiral carbon. When we look at option B and when we look at this carbon atom, this is not an asymmetric carbon atom. As three hydrogen atoms are attached here, this carbon atom is not an asymmetric carbon atom as two of the chlorine atoms are attached to it. When we look at this carbon atom, then this is not an asymmetric carbon atom. This carbon atom is also not an asymmetric carbon atom because multiple hydrogen atoms are attached to the carbon atom in option C. When we look at this carbon atom here, this is not an asymmetric carbon atom as two hydrogen atoms are bonded to it. But when we look at this particular carbon atom, there is one methyl group attached to it. The second group attached to it is a hydroxyl group. The third group that is attached to it, it comprises of one carbon atom, one bromine atom and two hydrogen atoms. And the fourth group is a hydrogen atom. Hence, all the four groups that are attached to this particular carbon atom are different, they are unique. And thus, this is a chiral carbon atom or an asymmetric carbon atom. We highlight the asymmetric carbon atom in yellow. Thus, we observe that compound D is the only compound having an asymmetric carbon atom, and thus option D is the appropriate answer to our question.